Hello people, and welcome back to my series on object-oriented programming. In this episode, we're going to take a look at an extremely simple object-oriented program. So let's go ahead by opening up our oop.h file, and in here we have an extremely simple object-oriented design where we have something called shape, which is a base class. It has a protected x and y variable, which is just a location. And protected in C++ means that these variables are essentially private, but they are still visible to any class that is derived from this base class. We have a constructor, so we give the shape location, and we'll start with location. We also have a couple functions called getX and getY, which will just return the location. We also have a move function, which will change the x and y values. And we also have a virtual function for the area of the shape. In this case, we have this equals 0 at the end here, and what that means is this is a pure virtual function. And pure virtual functions, all that means is that the base class will not implement this virtual function, that the virtual function needs to be implemented by any classes that derive from this base class. Now, a couple things that you might notice here is that everything is all in this 1H file. In a real project, you'd probably put each class in a different file. And another thing that you might do in a real project is have separate compilation where the implementation of your methods is put in a separate file from the declaration of your classes. So essentially, normally your declarations just go in an H file, and then your definitions will go in .cpp file. But since this is such a small and simple example, I put it all in one file. So for the rectangle class, it derives from shape, and it has its own private variables width and height, and it has a constructor, and then it also has the it overrides this virtual function area and has its own implementation where it's the width times the height. Triangle has a similar implementation, and the major difference there is it has its own implementation of area where it's the base times the height divided by 2, which is the area of a triangle. So let's go over here and take a look at our main function, or our main program, and all it does is it creates an instance of each shape type that we have. So we have a rectangle, we have a triangle, and we give them, rectangle has a position of 1, 1, triangle has a position of 2, 2, and rectangle has a width and height of 3 and 4, and triangle has a base and a height of 4 and 4. And all this does is it illustrates how inheritance works in object-oriented programming. So we have this base class shape, and we have these other two classes which derive from shape. And if you notice here, I'm doing r.get, so we have a rectangle, and we're doing a getx and a gety. If we look back in our rectangle class, you'll see that there are no methods for getx and gety in our rectangle class, and that's because those exist in our shape class, and we derived our rectangle from shape. So instead of having to write getx and gety again, we just use what is already available to us in our base class. And the same goes for the triangle function. We can have getx and gety. It inherits that from the base class. So this is part of the dry principle. Don't repeat yourself. And in this case, we save ourselves from having to write the same functions over and over again by using inheritance. We also have, we're also testing our area function, which will hopefully calculate the areas of our two shapes according to their own definition. So in the case of a rectangle, it should be 3 times 4, which is 12. And in the case of our triangle, it should be 4 times 4 divided by 2, which should be 8. So let's test this out. We'll use G++, and we'll use the C++ 14 standard, and we'll run it, and it looks like it works. So our rectangle is at position 1, 1. It has an area of 12. Our triangle is located at 2, 2. It has an area of 8. So that works, and that was just an extremely simple example of object-oriented programming. Thanks for watching, people. Till next time.